All right. So what we had done is last class was unit. We were starting with unit cell, right? We did the periodic structure. All right. So we'll start. We'll write this thing, unit cell. All right. Now, what is a unit cell? So unit cell, you can. This is one way of saying that it is a region of space which, when repeated and stacked together, okay, reconstructs the full periodic structure. So it is a region of space okay, which when repeated and stacked together all right. Now this stacking is also called as tiling. Okay, so tiled together. You must have had, like, of course every house has a tile. All right, tiling in floor or the walls. So this is the same word. Okay, tiling. So if you see in the tiles, there is no gap in between the tiles. All right. So that is the same thing. So you can think of that space. You have a 2D wall or a 2D this thing. Of course, it's in 3D, but the layer is 2D, right? Two-dimensional plane. So in that, there is no gap in between. All right, it's very close together. All right. So the same way we use this concept of unit cell. Okay, it is a region of space which is when repeated and stacked together, which is this stacking is called the tiling, reconstructs all right, the full periodic structure. The full periodic structure. All right. Now, all right. So now, yes, last class we had done this thing, a periodic structure diagram. All right, we can use the same diagram. I'll not draw it. I'll just show it once. So you can think of it like this structure which we have here. Okay, we can take this one of them. All right, you can I'll just highlight that part. Okay, so this part. Oh. So you can see this thing, this region. So this is a unit cell. Okay. So there are several of them. You are joining them together. Okay. So if I draw the shape here, okay, if I try to draw the shape here, now the same shape wouldn't be possible, but I'll try. So this is the shape we have. So it's a parallelogram, right? So this is a cell for unit cell for this structure. All right. Can you see this? All right. So this is a unit cell for this periodic structure, and this is what we are getting in this thing. Now, next point, unit cell. Okay. Tiles. Now there is another way of saying it in a single line. Previous was also a single line, but it's a shorter line. Cell tiles space and reproduce the periodic structure. Okay. Now, next point is they fit exactly. They fit exactly. All right. With no spaces. With no space between them. All right. So this is very important. There shouldn't be any space. Otherwise, it cannot be used as a unit cell to cover the whole space, or cover the whole structure. All right. Now, next is primitive unit cell. Primitive unit cell. All right. So this is, I'll just use this. This is not a standard thing, but for my lecture, I'll use this PUC. All right. So this is a primitive unit cell. So I'll just use the abbreviation in diagrams mostly. So this is so a primitive unit cell is a unit cell, okay, containing exactly one lattice point, full stop, okay, nothing else. So a primitive unit cell okay, is equals a unit cell containing exactly one lattice point. Exactly one lattice point. Okay, so these definitions are very important. Whenever you are asked to distinguish between a primitive unit cell and a conventional unit cell, all right, different types of unit cells. So this is very important. It doesn't talk about the atom. Okay, be clear. It talks about this. So it's better to use black here so that I can highlight this. Oops. So exactly one lattice point. Okay, so this is not atom, lattice point. All right. So next is, I'll give you an example. All right. So let's say this is the this is a structure given to you. Okay. Okay, this is a structure given to you. Now, I can define this cell as like this. All right. These are two cells. So I'll divide this. So this is one each. Like there are two cells here. Okay. So these cell, each of them contain one lattice point. All right. So there is one lattice point. All right, and these two of them, both of them, can be said to be like these, both the structures. Okay, the red boundary, like together with that lattice point, forms this thing, the PUC. Okay, primitive unit cell. Now we can see that if you just repeat this thing, keep on repeating throughout the space. Okay, so this will, what will it do? Primitive unit cell tiles. Okay, tiles space and contains only one lattice point. Contains only one lattice point. All right. Is this clear? Whenever I say tiles, means it doesn't have any gap in between. Okay, tiling is that. Just remember it, the tiling of your floors and walls. All right. Now, very important thing, very important statement. Note, primitive unit cell is not unique. You can have multiple primitive unit cells for a single crystal structure, periodic structure. All right. So I'll give you an example. I'll give you some examples. Okay, some examples of structure. Let's say we have this as the lattice point. Okay, lattice. We have this structure. Let's say. All right. Now you can draw the POCs like this. So you can draw the POCs like this. Now this is a line. This is not a POC. Okay. So when the structure is complete, then you see the POC. All right. So this is, if I just pull a line in between this, okay, this could be one of the structures coming in between. You can see, like forming between the lines, could be a PUC. All right. So let me make it even. So this is a PUC. Okay, I just made 3 of them in between. All right, others you can just imagine. Okay, so this could be one PUC. This one. All right, this in the same lattice structure. If I can draw like this. All right, in the same lattice, I can have the PUCs drawn like this. Okay. So let's say we have this structure. Now these lines are it should be parallel to each other. It need not be, but because in some structures there will be some other lines which won't be parallel. Okay. Now the other lines could be like this. So this is what you can have, all right? The other structure which we can have, all right? Now this can also be, because the main object this thing, single lattice point in the structure, okay, that will be called a PUC, all right? So this is also a PUC. Similarly, we can have another structure. Okay, similarly, we could have another structure. It need not be placed at the center. Okay, the way I have drawn it in these two things, it's almost at the center. All right. So it could happen that the lattice point is not at the center. All right. It's maybe it's like this. The structure could be like this. Okay. So the concept that you should not think that this lattice point has to be at the center of the cell. Okay, it could be anywhere within the cell or maybe at the on the boundaries. Okay, but then it should all the points should whatever the points have should add up to 1. All right. So this is another structure which we can have. So this is also a PUC. So one of them could be said it's a PUC. The reason is only single lattice point. That's it. Okay. So I'll give you some just a small example to work out.
Sir.
Yes.
Sir, I have learned the definition about PUC is that a unit cell where each lattice point are at the corner. Whether this definition is wrong, I don't know.
Sorry. Can you repeat?
Sir, definition of PUC I have learned is that all the units or a unit cell which lattice point are at the corner. Is this definition is wrong, sir?
Which book did you refer to?
सर मैंने भी यही पढ़ा है.
वही बोल रहा हूँ, कौन से बुक में पढ़े हो? बुक्स में भी कभी गलत लिखा होता है.
सर NPTEL का वीडियो से लिखा है सर.
देखो कॉर्नर्स में जरूरी नहीं है होना. लैटिस देखो वही तो इसलिए मैंने बोला ना, ये जो स्टार्टिंग के 2-3 लेक्चर होंगे ना बहुत इंपॉर्टेंट होंगे, इसीलिए हम लोग क्वेश्चंस में मिस्टेक करते हैं बहुत बार. ठीक है, इट इज नॉट रिक्वायर्ड, इट डज नॉट रिक्वायर यू टू हैव अ यूनिट सेल, be it primitive or conventional, to have the lattice point or at the corners. Okay, it's not it's never you can have. That is what I am going to show you ना. Example question अभी मैं दिखा रहा हूँ, उसमें आपको पता चल जाएगा क्या आप जो बोल रहे हो और मैं बोल रहा हूँ. ठीक है. What you are saying is it is one of the definitions. It's not like कि वो corner में होगा. ठीक है. It could be anywhere. The lattice point can be anywhere within the cell. Okay, it has to be within the cell. अगर सेल में नहीं आया तो फिर लैटिस पॉइंट काउंट नहीं कर सकते आप. वो सेल ही नहीं, फिर सेल है ही नहीं फिर वो. ठीक है. प्रिमिटिव यूनिट सेल स्टार्टिंग प्रिमिटिव यूनिट सेल्स होता है जहाँ पे एक होता है, एक यूनिट सेल, एक लैटिस पॉइंट होता है. अब धीरे धीरे कन्वेंशनल यूनिट सेल में जाएंगे. कन्वेंशनल यूनिट सेल में क्या होता है कि आपका ज्यादा होता है उसमें नंबर. ठीक है. तो ये मैं आपको जो कह रहा हूँ ना, ये दिस विल क्लैरिफाई ऑल द थिंग्स. अभी एग्जाम्पल देख लो. ठीक है, उसमें आपको क्लियर हो जाएगा. तो तो NPTEL के वीडियोस में। अच्छा, एक बार बताना मेरे को कौन सा लेक्चर है किसका, मैं अभी एक बार देखूं क्या है उसमें। कोई कंटेक्ट, बहुत बार कंटेक्स्ट भी होता है। एक बार मेरे को स्टूडेंट आके बोला, सर पता नहीं मैंने बताया कि नहीं ये जो चीज़, सर ओम्स लॉ गलत है। तो मैंने बोला गलत है? अरे इतने सालों से लोग पढ़ रहे हैं, तुमको पता चल गया गलत है, बाकी लोगों को पता नहीं चला। बता दो स्टोरी।
सर वो एक्चुअली है ना, ये जो प्रिमिटिव सेल है सर, हम प्रिमिटिव यूनिट सेल की बात कर रहे हैं। जो मैंने बुक में पढ़ा सर, बुक में प्रिमिटिव लैटिस में दे रखा है ये कि कॉर्नर्स पे होते हैं।
नहीं तो वही मैं कह रहा हूँ कि जो ओम्स लॉ वाला स्टोरी बताया था मैंने आप लोगों को।
नहीं सर।
नहीं सुनो, तो मेरे को स्टूडेंट आके बोला, सर ओम्स लॉ गलत है। मैंने बोला अरे बाप रे बाप, तुमने मतलब गलत कैसे बोल दिया? भाई गलत है, ठीक है भाई गलत है, कहाँ पढ़ा है? रेसनिक हॉलिडे में पढ़ा है। हम अरे बाप रे, तो बहुत बड़ा बुक है, ठीक है, ये तो मतलब फेमस बुक है, कैसे उसमें कैसे ऐसे लिख दिया? फिर ठीक है भाई, पेज नंबर खोलते हैं, कहाँ लिखा है, कहाँ पढ़ा है, देखते हैं। तो मैंने पढ़ना शुरू किया, तो पढ़ा मतलब पहले भी था, बहुत पहले पढ़ा था मैंने 12th में। तो मैंने पढ़ना शुरू किया, तो उसने बस वो लाइन पढ़ा था कि ओम्स लॉ इज नॉट अ लॉ, ठीक है, ये लाइन पढ़ा था, बाकी आगे पीछे पढ़ना भूल गया। ठीक है, आगे पीछे क्या लिखा था कि ओम्स लॉ जस्ट लाइक होल्ड्स फॉर लीनियर सर्किट्स, लाइक लीनियर मींस रेजिस्टेंस हो गया, ठीक है, डायोड्स के लिए होल्ड नहीं करता है, ऑलराइट। सो नॉन लीनियर जो कंपोनेंट्स है उसके लिए होल्ड नहीं करता है, इट्स अ रूल, इट्स नॉट अ लॉ, ये कहा था रेजिस्टिंग रिलेटिव में। उसने समझ लिया भाई लॉ गलत ही है, ठीक है। तो ये मैं कहता हूँ कि आपने अगर जो पढ़ा है, मेरे को या तो उसका जो पेज नंबर है या बुक बताओ या वीडियो बताओ मेरे को, ठीक है, मैं देख के अगर आपको नहीं समझ में क्लैरिफाई हुआ कि क्या मतलब उसमें और मेरे में क्या डिफरेंस है, मैं जो बता रहा हूँ, ठीक है, तो वो मैं फिर आपको बता दूंगा कि उसमें और उसमें मेरे में क्या है डिफरेंस। बट जो मैं ये बता रहा हूँ आपको, ठीक है, दिस इज लाइक फ्रॉम स्टैंडर्ड बुक्स, ओके, सो देयर वोंट बी एनी प्रॉब्लम विद द कॉन्सेप्ट, ऑलराइट। तो इसीलिए मैं बोलता हूँ हमेशा कि जब भी आप पढ़ रहे हो मेरे से, तो पीछे जो पढ़े हो ना उसको थोड़ा सा साइड में रखो, इसको पहले एक्सेप्ट करो, ठीक है, तभी आप सीखोगे। अदरवाइज आप सोचते रह जाओगे कि अरे इसमें सर ने ये बताया, मैंने वो पढ़ा, ऐसे चलता रहेगा, फिर आप ना ये सीख पाओगे और जो सीखे हो उससे क्वेश्चन तो बनेंगे नहीं। फिर हो सकता है बन जाए, मैं ये नहीं कह रहा हूँ कि नहीं बनेगा, बट जो बहुत कॉन्सेप्चुअली डिफिकल्ट क्वेश्चंस होते हैं ना, उसमें यही सब डिफरेंसेस मैटर करता है फिर, ठीक है। ये बड़ा कॉन्सेप्ट डिफरेंस नहीं है जो आप कह रहे हो, ठीक है। अभी एग्जांपल देख लो, एग्जांपल देख के अगर समझ में आपको लगे, लेकिन मेरे को जो है ना, जब भी आप बोलो ना कि मैंने ये पढ़ा है वो पढ़ा है, मेरे को प्रॉपर रेफरेंस दो, ठीक है, तभी क्लैरिफाई कर पाऊंगा कि जो मैं बता रहा हूँ और उसमें क्या मतलब प्रॉब्लम आ रहा है, ठीक है। तो इसमें प्रॉब्लम नहीं है जो मैं बता रहा हूँ, ठीक है। हो सकता है वो भी सही कह रहा हूँ, बट वो अपना कंटेक्स्ट देखना पड़ेगा, हमें कंटेक्स्ट देखना पड़ेगा किस कंटेक्स्ट में कह रहा है वो, ठीक है, वो इंपॉर्टेंट है, ऑलराइट। सो मेरे को या तो भेज देना वीडियो का लिंक, मेरे फोन नंबर तो है ही मेरे आप लोगों के पास, सिंपल। अच्छा, इसमें मैं आंसर क्यों लिख रहा हूँ, ये डायग्राम बनाना था मेरे को, ठीक है, तो ये डायग्राम बना दिया मैंने, एक ये बना दिया, ठीक है। तो अब बताओ क्या ये प्रिमिटिव यूनिट सेल है या नहीं है? ये तीन है ना आपके पास?
तीनों है सर।
तीनों है, ठीक है। तीनों कैसे है एक एक करके देखते हैं। इसमें लैटिस पॉइंट कितने हैं? दिस इज अ प्रिमिटिव यूनिट सेल, प्रिमिटिव यूनिट सेल, ऑलराइट। तो यहाँ पे लैटिस पॉइंट 1 लैटिस पॉइंट, ठीक है, ये दिख रहा है हमें 1 लैटिस पॉइंट। नाउ लैटिस पॉइंट को हम 1D में एक 2D सर्कल की तरह लेंगे, ठीक है, और 3D में एक स्फीयर की तरह लेंगे, स्मॉल स्फीयर की तरह। तो यहाँ पे जो है, अगर हम इसको थोड़ा जूम इन कर लें इसको, ठीक है, इफ वी जूम इन, ठीक है, स्ट्रक्चर को थोड़ा सा, तो हमें ऐसा कुछ दिखेगा, ठीक है। ये मान लो जूम इन कर लिया, और ये जो आपके पास डॉट्स हैं, ठीक है, वो ऐसा है, ठीक है, ये ठीक है, एक ऐसा है और एक ऐसा है।
सर आपकी रिदम हिंदी में हो गई सर, बाकी कुछ स्टूडेंट्स को ना भी समझ आ रहा हो शायद।
अच्छा, नहीं नहीं कोई बात नहीं, वो देखो जिसको जब लगे कि मैं हिंदी बोल रहा हूँ या इंग्लिश में बोल रहा हूँ तो आप बता देना कुछ जहाँ पर समझ में ना आए, ठीक है। तो क्योंकि मेरे को पता नहीं चलता ना कि मतलब क्या, मतलब अब जो बोलने लगता हूँ तो बस बोलने लग जाता हूँ, ठीक है। तो उसमें आप यू कैन टेल मी दैट व्हेनेवर आई एम नॉट लाइक यू कैन नॉट अंडरस्टैंड मी और इन द लैंग्वेज और समथिंग लाइक दैट, यू कैन just interrupt me there, okay? I'll change quickly, not a problem. If you want me to speak in Bengali, I can do that also, but Bengali crowd will be very less. Okay, so yeah, so this is, if you can zoom in, so this is a zoom in, okay? So this, if I zoom in, तो ये ऐसा दिखेगा, ठीक है। लैटिस पॉइंट, ये लैटिस पॉइंट्स हैं जो ये मैंने बना रखा है, ये लैटिस पॉइंट्स है जो मैंने इनलार्ज कर लिया है, ठीक है। तो यहाँ पे देखो जो कंट्रीब्यूशन है, ठीक है, ये भी लैटिस पॉइंट है और ये एक ऊपर भी लैटिस पॉइंट है, ठीक है। दिस इज ऑल्सो लैटिस पॉइंट, ऑलराइट। नाउ इन दिस if you see now how do you divide the contribution, now we want the contribution, okay, what is the contribution of this lattice point to this unit cell, okay. So in this one I'll ask a question, what is the contribution, okay, what is the contribution of each lattice point, okay, in the यूनिट सेल। नाउ हमें पता नहीं अभी तक कि यूनिट प्रिमिटिव है या नहीं है, हम अज्यूम कर रहे हैं, हमें पता नहीं। तो यूनिट सेल हम बोल रहे हैं उसको, ठीक है। वी आर सेइंग दैट इट्स अ यूनिट सेल। नाउ लैटिस पॉइंट, व्हाट इज द कंट्रीब्यूशन? नाउ यू कैन सी लाइक हाउ मच एंगल, लाइक व्हाट इज द टोटल एंगल इन अ सर्कल, like the by subtended by the circumference at the center,
2 pi.
2 pi, right? 360. So this is 2 pi. So we have, this is 2 pi, right? Now what is, if you see at the, in the diagram, the lattice point, oh, sorry, so if you see in the diagram, okay, so what is there, how much is the angle subtended by the part which is inside the unit cell?
Right.
All right, if I just I'll draw it again here. So in this case, if you see this, this is the line passing through. All right, this is the line passing through. So I'll get rid of these. Okay, so this is the lattice line passing through. All right, it's the same thing here. I'm drawing. This is again zoomed in. Okay, so in this case, you see what is the angle here. What is the angle inside, angle subtended by the part inside the unit cell? So this is inside, okay. This part is inside PUC. This is outside PUC. All right. So what is the angle here? So this is pi. Now the total angle is 2 pi, right? This total angle is 2 pi. And inside this is this pi. So what is the contribution, we can say, the fractional contribution of each lattice point?
Half.
Half. So fractional contribution of each lattice point. Okay, to unit cell. Okay, so how do you get it? You can just take the ratio. So inside angle and the total angle. Inside angle, I mean the angle which is within the unit cell. Okay, so angle within the unit cell means the part which is subtending the angle at the center. Okay, so total angle. Okay, so this is, here it is pi and 2 pi, so we'll get 1 by 2. So each contributes 1 by 2. Okay, So each contributes, this contributes 1 by 2. Okay, this contributes 1 by 2, and similarly this is also similar point, same lattice point, so it contributes 1 by 2. So the total contribution becomes, so total contribution of lattice points, okay, in the unit cell, all right, is equal to, we have each contributing half, and there's number of unit cell which is contributing is 2. So we have one lattice point in unit cell. All right. So this implies what? This implies the unit cell is a the given unit cell is a primitive unit cell. The given unit cell is a primitive unit cell. All right. Now, similarly, what about this one? So let me label this one. So this is number 1, this is number 2, this is number 3. So this is number 2. All right. Now, what about number 3? What about number 3? What is the contribution of each of them?
1 by 4.
Okay, so everybody is getting the idea. So for figure, for unit PUC, for unit cell 3, unit cell number 3. All right. So I'll just bring it here. So if you just zoom in, okay, if you just zoom in, so I'll just reuse the diagram here from here. Okay, same component, so I'll just reuse. So we have, this is the plot, right? I'll just, so this is the plot we have, and then I'll just take this one and shift it to this point, and then take this one and shift it to this point, and then the other one, we can have this. All right. So this is the zoomed in version. So we have zoomed in. Right. Now these are the lattice points, and it's not perfectly placed, but you can get the idea. So what is the contribution of, if you see this thing? So if you have, again, if you zoom in again, so what do you have? You have a circle. Okay. You have a circle. All right. And then you have this lattice points. All right. This is the structure, right? So if you see the angle, so what do you have here? What is this angle?
Pi by 2.
Pi by 2. And again, what is the total angle subtended by the circle? 2 pi. Right? Now, if you try to find the contribution of each lattice point to the unit cell, All right. So this you can directly write this down. Pi by 4 is the angle inside the this thing, and this is a 2 pi. Okay, so pi by 2. So this is, if you see this, you get 1 by 4. Okay, each contributes 1 by 4. And how many points are there? So the total lattice point, point, okay, inside total number of lattice point inside unit cell, okay, is equal to contribution of each unit lattice point to the unit cell multiplied by the number of lattice points, okay, which are touching the this thing, the unit cell, points touching the unit cell. Unit cell boundary, okay, to be specific. So this is, here we have 4 of them. So 1 by 4 multiplied by 4, we have 1. So the lattice point is, so we have 1 lattice point. The total contribution is 1 lattice point. We are not talking about atoms. This is a lattice point. Okay. We'll talk about atoms later on. Is this clear? So all of them are primitive unit cell in this example. Now, unfortunately, this has turned to green color, black color. This was red. All right, this is clear. कोई doubt है इसमें?
No, sir.
So this is number 3. All right. Now moving on. Conventional unit cell. Okay. Conventional unit cell. Now, conventional unit cell are those unit cells which we take it like for our ease of calculation and ease of visualization. Okay. So, a conventional okay, unit cell equals so a conventional unit cell equals non-primitive unit cell, okay, that is convenient, which usually means orthogonal axis. Orthogonal axis means I'll give you an example here. All right. So conventional unit cell is not a primitive cell. All right. This you have to be very clear about it. So this is a non-primitive cell. All right. Means it can contain more. It will contain more than 1 lattice points. Okay. That is what a non-primitive unit cell means. Okay. Non-primitive means more than 1 lattice can contain. Now, conventional unit cell can be a primitive unit cell. Okay, it can be, because then otherwise, since if they are both different, then only use the word conventional and primitive unit cell separately. If they are the same, there is no use of using the conventional unit cell. Okay, so can contain. In fact, will contain more than 1 lattice point. All right, non-primitive means. Now let's take an example. So this is a structure. All right, so let me draw it a little bit bigger. Okay, so there's another layer. All right, so if I draw this thing, so I'll draw a structure here. So these dots have a bit shifted. So I'll draw this unit cell. Okay, so this is one unit cell, and then I think I would require one more layer to fit in the other structure. So I'll extend it this way. All right. Now, in this case, we can have so I think I made wait a minute, let me redraw the diagram. Okay, so let me. I just drew the lattice, the diagram a bit wrong. Okay, so this is the structure. So this is the structure. Okay, there was some confusion in that. All right, so this is the lattice points, and then we have the structure. One structure is this. All right, and then the other structure is this. All right, now tell me which one is a or unit primitive unit cell and which one could be used as a conventional unit cell. Now this one is a PUC, right? Why? In this you can see the contribution. If you just draw it, draw a bigger one. Okay, so just got flipped. I cannot flip it, right? So it's better to draw it. So I'll just draw it here. Okay. All right. Now, if I draw the circles here, I draw the circles here. Okay. Now this is a zoomed in version. So tell me, what is the total number of is this I already said it's a PUC. So what are the angles subtended here? Can you tell me? What is the angle here? What is this angle? Let's say it's theta. Okay, I'll just give you theta. What will be the other angles? This one, this one, theta. This is pi minus theta, and this one theta, and this pi minus theta. So if you add up all the angles inside, okay, if you add up all the angles inside, how much you will get? Pi plus, sorry. So we have 2 theta and then we have 2 pi minus theta. If we add all the angles, so what will you get? 2 pi. Okay. So you can see the total contribution is 2 pi. Total angle is 2 pi. Okay. So you can calculate the number of this thing. So contribution, you can say the number of unit cell, number of lattice points, number of lattice points inside unit cell is equal to, so we have the, so we will just find the contribution and number of this thing lattice points. So number of lattice points is 4 and the contribution here for each one is, so what will be there? Contribution of each of them. So here we cannot just take the ratio, like it will be like this. So you'll have this kind of thing. So we have theta by 2 pi, then we have pi minus theta by 2 pi plus theta by 2 pi plus pi minus theta by 2 pi. Okay. So either we could have taken the total angle and divided by the total angle, a single lattice angle. So we could have gotten 1. Okay. So what we are doing here is we are just adding them up. All right. So we have added. So we don't need to multiply. In that the angle was same. So we had to multiply 4. So this is the total contribution you have. So this is the fractional contribution of each of them. So this is the one lattice point. Okay. And you can see the axis here is not orthogonal. Okay, the axis here. Okay, this is very important here. That is why you used a conventional unit cell. Axes are not orthogonal. Okay, the theta is not equal to 90 degree here. Theta is not equal to 90 degree. So if theta is not equal to 90 degree, pi minus theta will also be not equal to 90 degree. Okay. Now what about this one, the other one? How many lattice points are there?
2 है सर.
तो सबका कंट्रीब्यूशन देख ले, अभी समझ में आ गया ना कैसे कंट्रीब्यूशन निकालना है. इसका कंट्रीब्यूशन कितना होगा कॉर्नर वाले का?
1/4.
1/4, 1/4, 1/4 और बीच वाले का?
1 सर.
1. So total lattice points कितने हो गए? Total lattice points is equal to 1/4 into 4 plus 1. So this is 2 lattice points. देखो मैं एटम्स मत ले आना यहाँ पे, एटम्स हम कंट्रीब्यूट नहीं कर, है ही नहीं एटम्स यहाँ पे. So 2 lattice points. So this is a conventional unit cell. Okay. So this is a contribution from corner lattice points, and this is a contribution from central lattice point. Okay, so this is a conventional unit cell. This is a conventional unit cell. Okay, and what is this thing? You can see the axes here are orthogonal. Okay, the axes here are orthogonal. Okay, so orthogonal axis. All right. So it's easier to use some, like that is why the name, like we have, it is convenient to use. All right. So this is the difference between all the cells, unit cells. Okay. So we have learned the unit cell, primitive unit cell, conventional unit cell. All right. Is this clear? So moving on. Now we have another way of constructing a primitive unit cell, which is the Wigner site cell. Wigner sites cell. ओके तो यहाँ पे क्या करना है, यहाँ पे आपको एक एल्गोरिथम फॉलो करना है. एल्गोरिथम पता है क्या होता है? व्हाट इज एल्गोरिथम? Steps. It's a steps as procedure you follow to accomplish something. Okay, so like a recipe is an algorithm for some food. Okay, the dishes you make. Okay, so this is one of the algorithms to construct a primitive unit cell. One of the algorithms to construct a primitive unit cell. Alright. Now let's see how to do it. Now I'll just draw the figure, then I'll note down this thing. Okay, let me draw the figure and then we'll. Okay, and then we have a central that is here, and then so okay. ठीक है, तो ये लैटिस पॉइंट्स हैं. ऑलराइट, और इसमें हमें विग्नर सीट्स बनाना है. तो देखो कैसे बनाएंगे. ओके, सो जस्ट कनेक्ट ऑल द नेबरिंग पॉइंट्स. इसके अराउंड बनाना है. ठीक है, इस पॉइंट के अराउंड बनाना है अपने को. ऑलराइट, तो कनेक्ट ऑल द नेबरिंग पॉइंट्स ओके टू दिस थिंग with straight lines. Okay, so I'll directly connect two of them together. All right, straight lines draw कर लेते हैं to all the neighboring points. All right, this is the first step. Now draw perpendicular bisectors or to each of the lines. Okay, so it's difficult to get the accuracy, but I'll still try. So the midpoint of, let's say this is this, and the midpoint of this is, let's say, this one. The midpoint of this is this one. Okay, I can get the midpoints easily here. Okay, now this one will be somewhere here, this will be somewhere here, and then this will be somewhere here. Okay, get the midpoints and then draw this lines. Okay, draw the lines perpendicular bisectors. Okay, so draw it perpendicular to this. draw perpendicular lines. ठीक है, तो ऐसा कुछ स्ट्रक्चर बनेगा और दो पर्टिकुलर जो लाइंस हमने बाकी जो दो होंगे वो क्रॉस नहीं कर रहा है यहाँ पे. ठीक है, हमें जो सबसे स्मॉलेस्ट जो बनेगा जहाँ पे कट द in this case these lines won't intersect with the other lines. All right, so this won't form the structure. So what do we have here? Okay, if you see this structure, now this one, okay, this is a structure. Now I can, so this is a structure. Okay, we have, if I join all of them, so this is a structure. It's not it's not as perfect I want it to be, but it does the job. All right, so this is the beginner side cell. So you can see how many lattice points are there inside. How many lattice point? One lattice point, right? Beginner sides cell. Okay. All right. So this is a bit of all right. Now let's write down whatever I said. Okay, the steps. So steps to construct a primitive unit cell. All right, number one, draw lines to connect. Draw lines to connect. Okay, a given lattice point, a given lattice points. All right, to, not lattice points, lattice point to all the neighboring points, all the nearby lattice points. All right, and number two, at the midpoint, okay, at the midpoint and normal to these lines, okay, draw new lines. Draw new lines, which are the perpendicular bisectors. Okay, perpendicular bisectors. All right. Now, in this case, it is like 2D structure, so we have lines. Okay, or planes. Okay, planes in 3D. In 3D also we can apply the same concept, but in that case we don't do lines, we draw the planes. Okay, instead of a line, okay, we'll join each of the neighboring points and draw planes like having a like normal to these lines. Okay, so in that case we have a volume, okay, occupied. Here we have a surface area, All right. Now step number 3. The smallest volume enclosed, okay, enclosed in this way, the smallest volume enclosed in this way is the Wigner-Seitz cell. All right, Wigner-Seitz primitive cell. In fact, this is a primitive cell, primitive unit cell. Is this clear? All the steps?
Yes, sir.
Okay, so now there is another way of looking at it. Okay, this I'll just mention this. So Wigner-Seitz cell, Wigner-Seitz cell, okay, encloses the region around, okay, the lattice point, around the lattice point, all right, which is closer to the lattice point, all right, than to any other lattice points. Okay, if you see closely, this region, the region inside this, okay, this is closer to this point, okay, than to any other lattice points in this neighboring area. Okay, so there is another way of saying, looking at the Wigner-Seitz cell. So there is another cell which is beyond, which is not. It's in. I think it's taught in mathematics maybe. So it's a similar concept like this, which is also used for pizza delivery. Okay, like to get, which is a nearby location center to deliver you the pizza within half an hour. So these things have connections to practical things also. All right. Okay. So now next topic is basis. Okay.
Sir, please
Yes.
explain once more.
Which one?
Sir, the last one. Wigner-Seitz cell encloses the region around the
lattice point, which is closer to the lattice point than to any other lattice points. Means if you just take this thing, if you take this region, okay, if you take this region, this whole region, if you take any point inside this region, okay, this is closer to this lattice point around which we have drawn the Wigner-Seitz cell, then this point, then this point, then this point, then this point. If you measure the distance, okay, this will have a smaller distance to this, okay, like and it will be nearest to the lattice point about which we have drawn the Wigner-Seitz cell. If you take any points inside this region, so that is what it means.
Okay, sir,
all the points inside this region will be closer to this lattice point, the central lattice point, than to any other lattice point in the neighboring area. All right.
Yes, sir.
Okay. So next is basis. So it is a description. It is, yes.
So last point was proved mathematically, or it was just an observation?
No, you can prove it, right? It's a mathematical proof also, and you can prove it yourself also if you think a bit harder. All right, if you can define it, so you can mathematically there is a proof. I forgot the name exactly. There is another algorithm which is similar to this. Okay, so yeah, it can be proven here also. Visually you can prove it, but you can show it. But yeah, there is a proof also. All right. Now, description of an object. Okay, it is a description of an object. Object, it could be atoms or molecules, whatever it is, in the unit cell. Okay, in the unit cell, with respect to a reference unit, with respect to a reference lattice point. Reference lattice point. Okay, we take a lattice reference. This is the important part that this is. So it's a description of an object. Okay, and with respect to a lattice point. Okay, this is it. Don't think about anything else. So I'll give you an example. Okay, to help you understand better. So let's take a lattice which looks like this. So we have a lattice like this. All right. Yeah. So we are done with the lattice. Now, we are giving an example of diatomic basis. Okay. So this is supposed to be example of diatomic basis. Oh, I left 2 points hanging. So this is example of this is diatomic basis. Means the basis consisting of 2 atoms. Basis consisting of 2 atoms. All right. Now, this is a lattice. I have given you the lattice. Now, in this lattice, so this is the lattice we have. All right. Now, I give you a diatomic basis. Okay. It looks like this. So we have, say, a blue atom. Okay. And then we have, let's say, a black atom. Okay. So these are 2 atoms. All right. So this is a basis. This is a diatomic basis. All right. This is a diatomic basis. Now, we want this structure to be placed on the lattice to construct a periodic structure, right? Now, in this case, this is very important. Okay, listen carefully. If you cannot, like, you can take the notes, but just look at the screen. Okay, all right, for some time. So this is a diatomic basis I have defined, but 2 atoms are there. And then I have to construct the periodic structure. Okay, what I do is I place this structure. Okay, I take this whole structure. Okay, and then place it on the lattice points. All right. So I take the blue atom. Okay, the black is attached to it. Okay, I take the blue atom and place it on the lattice points. So what structure will we see finally? So let's draw it. So let's start. Let's say we have this structure. Okay, we place it from on this only, the point I have shown you. Okay, on these atoms the blue will be placed. Okay, on all these atoms, this one, this one, this one, this one. Okay, I'm placing the atoms here, the blue on the lattice points. Everywhere the blue is there. Okay, on the lattice points I'm putting in blue, or I'm already showing it with this thing. So let me use some different color, maybe green. The second atom. Yeah, this is better. So we'll start with this one. So I'll just place all the blue ones. So I'll just take this and reduce my work. Okay. And paste it down below here. So if I select all of them and change it to blue. Okay, so this is I have placed all the blue atoms, okay, on the lattice. I have placed all the blue atoms on the lattice. Okay. Now, along with it, the green atom will also be there. So where will the green be placed? Green will be placed halfway. Okay, so this, I think it has to be placed properly. So the green atoms, you can see the distance between that. Okay, so this, let's say this was a distance, let's say 2a. Okay, this is a, it's half. Okay, this is 2 square is 1 square. Okay, so we'll place it halfway. So I'll place the atoms, green atoms, in these positions. All right. These are not the lattice points. The green ones are not at the lattice points. Okay. The blue atoms have been placed on the lattice points. The green atom is tagging along the blue atoms. So we have this structure. This is a periodic structure, right? Now, what do we have? We have like you can see this thing. You can see this structure. I'll just draw it like this. This is the same thing. This is the diatomic basis which we have. Okay. Which we have placed on the lattice points. And these are the lattice points. Okay. Underlying is the lattice point. These are the blue ones are the lattice points. All right. Is this clear? Up to this it is clear?
Yes, sir.
Now, if I tell you, yes, tell me.
ब्लू के अपर साइड और लोअर साइड भी तो जैसे ग्रीन पॉइंट आना चाहिए.
नहीं, ग्रीन आप एक साथ जो है इसके साइड क्यों आना चाहिए? ब्लू के साथ एक ही ग्रीन एटम है ना, 2 एटम थोड़ी है. ब्लू के साथ कितने ग्रीन एटम है? एक ब्लू के साथ कितना ब्लू ग्रीन एटम है? एक है ना.
ओके सर.
पेयर्स में जाएगा ना वो. ठीक है. ऑलराइट. सो दीज आर द लैटिस पॉइंट्स. ये लैटिस पॉइंट है पीछे, ये जो यही पॉइंट्स है. ठीक है. ये पॉइंट और ये पॉइंट सेम है. ऑलराइट.
सो ये पॉइंट पर रखे हैं, इसमें से एक एटम इस लैटिस पॉइंट को कवर कर रहा है, बाकी दूसरा वैसे ही है.
कवर क्या कर रहा है? उसमें कुछ है थोड़ी लैटिस पॉइंट. वो लैटिस पॉइंट के जगह पे वो रख दिया है हमने. मतलब लैटिस पॉइंट क्या है? एक मैथमेटिकल कॉन्सेप्ट है, राइट? इट्स फिजिकल, तुमको दिखेगा थोड़ी वो. फिजिकली इट्स नॉट प्रेजेंट ना लैटिस पॉइंट. वो तो हमने बनाया है स्ट्रक्चर, मतलब उस एजम्पशन उसको हमने लिया है कि हमने लैटिस पॉइंट डिफाइन किया, ये पॉइंट्स में ये है. चलो मान लेते हैं आपको दिख रहा है वो चीज. ठीक है. मुझे नहीं दिखता है, बट उस लैटिस पॉइंट्स पे हमने ब्लू और ग्रीन एटम को एक साथ प्लेस किया है. ऐसे प्लेस किया है कि ब्लू जो है, ब्लू इज ऑलवेज ऑन द ब्लैक पॉइंट्स. ओके तो समझ लो कि पीछे छुप गया वो, ठीक है, ब्लैक जो है ब्लू के पीछे छुप गया। ऑलराइट, क्लियर है इतना? आगे बढ़े। नाउ इन दिस इफ आई डिफाइन अ यूनिट सेल, ओके, इफ आई डिफाइन अ यूनिट सेल लाइक दिस, कुछ ऐसा मैंने बना दिया मान लो, ठीक है। इज दिस अ प्रिमिटिव यूनिट सेल और नॉट?
यस सर।
व्हाई?
सर उसमें एक लैटिस पॉइंट था जो जिसके ऊपर आपने ब्लू रख दिया।
हाँ, तो है यहाँ पे एक ही लैटिस पॉइंट अभी भी, ठीक है, यहाँ पे लैटिस पॉइंट एक ही है, बट एटम्स कितने हैं यहाँ पे?
2 है सर।
एटम्स यहाँ पे 2 हैं, तो दिस इज अ प्रिमिटिव यूनिट सेल। प्रिमिटिव यूनिट सेल क्यों? 1 लैटिस पॉइंट, ओके, बट एटम्स कितने हैं? एटम्स यहाँ पे देयर आर 2 एटम्स, ऑलराइट, देयर आर, ओह आर मिस हो गया, देयर आर 2 एटम्स, ऑलराइट, 2 एटम्स 1 लैटिस पॉइंट, ठीक है, कंफ्यूजन नहीं होना चाहिए। प्रिमिटिव यूनिट सेल में एटम्स की हम बात ही नहीं करते हैं, हम बात करते हैं लैटिस पॉइंट की। एक लैटिस पॉइंट है तो प्रिमिटिव यूनिट सेल, उसमें कितना भी एटम्स हो कोई मतलब नहीं अपने को, ठीक है। तो लैटिस पॉइंट एक है, प्रिमिटिव, इसमें प्रिमिटिव यूनिट सेल में 2 एटम है, क्योंकि बेसिस हमने क्या यूज किया है? डायटोमिक, ऑलराइट। हम और एक प्रिमिटिव सेल बना सकते हैं, कैसे? देखो, हम ये एक स्ट्रक्चर लेते हैं, ये प्रिमिटिव यूनिट सेल है कि यूनिट सेल है कोई?
प्रिमिटिव ही है सर।
तो मैंने आंसर बता दिया है, लेकिन कैसे इसमें प्रिमिटिव यूनिट सेल है?
सर 1/4 कंट्रीब्यूशन आ रहा है।
1/4 नहीं है, 1/4 नहीं है, ये 1/4 कैसे होगा? इसमें एंगल कितना सबटेंड कर रहा है? वो इक्वल 90 डिग्री थोड़ी बन रहा है।
थीटा एंड पाई माइनस,
हाँ, ठीक है, तो ये क्या हो जाएगा? प्रिमिटिव यूनिट सेल, क्योंकि यहाँ पे कितने लैटिस पॉइंट, इतने कंट्रीब्यूशन कितना है टोटल लैटिस पॉइंट का? एक ही है ना, जैसे हमने प्रीवियसली किया था। ये भी एक लैटिस पॉइंट, ये भी एक प्रिमिटिव यूनिट सेल है, प्रिमिटिव यूनिट सेल। ओके, और इसमें 1 लैटिस पॉइंट है, सॉरी हाँ 1 लैटिस पॉइंट है, ये तो सही है, 1 लैटिस पॉइंट। और एटम्स कितने हैं? टोटल एटम्स कंट्रीब्यूशन कितना हो जाएगा इसमें?
2 है सर।
यहाँ पे 2 एटम्स है। देखो 2 जो एटम का कंट्रीब्यूशन हम लैटिस पॉइंट की तरह जैसे हमने कैलकुलेट किया वैसे निकालेंगे, ठीक है। हम देखेंगे कि एंगल कितना सबटेंड कर रहा है, ठीक है, 3D में भी और 2D में भी, हम डिस्कस करेंगे उसको फर्दर। 2 एटम्स, ठीक है, क्लियर है? आप देख सकते हो कंट्रीब्यूशन, अगर आप निकालना चाहते हो आप देख सकते हो, देखो यहाँ पे इसमें इसका हाफ कंट्रीब्यूशन होगा इस एटम का, इसका हाफ होगा, ठीक है। बाकी ये 4 कॉर्नर का जो एटम होगा, ये मान लो थीटा है, तो इसका कंट्रीब्यूशन क्या हो जाएगा? थीटा बाय 2 पाई। इसका कंट्रीब्यूशन क्या हो जाएगा? पाई माइनस थीटा बाय 2 पाई, ठीक है। इसका कंट्रीब्यूशन क्या हो जाएगा? थीटा बाय 2 पाई। इसका कंट्रीब्यूशन क्या हो जाएगा? पाई माइनस थीटा बाय 2 पाई। सबको ऐड कर दो, ठीक है। तो एटम्स को भी हम उसी तरह से देख सकते हैं, जो कंट्रीब्यूशन है एटम्स का, हमने जैसे लैटिस पॉइंट का कंट्रीब्यूशन कैलकुलेट किया था। ऑलराइट, कर लोगे? ठीक है, देखो, हाँ यहाँ पे जो है आपका, जो हमने कैलकुलेशन किया, इसको मैं थोड़ा सा यहाँ पे लिख देता हूँ, ठीक है। यहाँ पे जो हमने लिखा है इसका कंट्रीब्यूशन इसी चीज का, कैसे कर रहे हैं हम? यहाँ पे जो ब्लू एटम्स का है, ओके, सो ब्लू एटम्स का हम ब्लू से बना देते हैं। तो यहाँ पे पाई माइनस थीटा, हम एटम्स कैलकुलेट कर रहे हैं, ठीक है, नंबर ऑफ एटम्स, नंबर ऑफ एटम्स, ओके, इसको हम नंबर दे देते हैं एक, 1 in 1. Alright, contribution हम ऐसे calculate करेंगे same. तो blue atoms के लिए हम लिख देंगे blue will write down like this. So we can add up like this. So pi ये यहाँ पे 2 बार आएगा इस तरह का, और एक we have 2 theta by 2 pi. This will also appear twice. Okay, this is one for the blue atoms, and for the green ones. Okay. So we have this is 1 by 2. Okay, basically I can write like this. So this is pi by 2 pi, and there are 2 of them. Okay, so 2. So these are the contributions. Okay, so these are this is the blue atom contribution. This is the green atom contribution. All right, if you add them up everything, all right, so what you will get? You will get 2. अगर ये पूछेगा how many blue atoms in a primitive unit cell, तब क्या बोलेगा? What is the answer to that? How many blue atoms in a primitive unit cell?
1, sir.
1. How many how many green atoms in a primitive unit cell?
1, sir.
1. But if they talk about atoms, then 2. ठीक है? इतना clear है? Is it clear till now?
Yes.
Now यहाँ पे जब भी हम count करेंगे atoms को, okay? So number of atoms, whenever we say atoms, so यहाँ पे I'll just add this thing here. We talk about blue plus green atom. So blue plus green, okay, in 1. All right. Now next is what can be a primitive lattice vector? Primitive lattice vector हम बहुत भूल गए, उस मतलब याद है I guess सबको. तो primitive lattice vector हमें बनाना है. So हमें एक lattice point से दूसरे lattice point jump करना है, मतलब जाना है. तो ये हो गया एक. दूसरा this, right? So we have a, let's say this is A2 vector, and let's say this is A1 vector. All right, is this clear?
Yes,
So
sir.
can we use this as a primitive unit vector, primitive lattice vector? Can we use this as a primitive lattice vector?
Yes, sir.
This pair. Yes, right? We have to go to blue ones. And once we get the blue ones, we know what the basis is. This is the basis, right? This is the basis we have. So we know how it's placed. It is placed at a distance this from the blue atom. So we can place the green atoms at that distance in each this structure, in each of the places. All right. Now, what is the reference here? What is the reference points here? Reference lattice points? The blue atoms, okay, where the blue atoms are kept. In this case, आप green को भी play करके बना सकते थे, ठीक है? We could have used green also in place of blue, and then place the blue ones. In this case, we have used the blue ones, blue atoms. So in this case, we are choosing, or we have chosen. Okay, we have chosen the reference lattice points. The reference lattice points. All right. On or at the blue atoms, or on the blue atoms. On the blue atoms. All right. Now, in this case, how we write the basis? So basis is written like this. When I say you write the basis, so there are two ways to what you do is you write this like this. You write the basis like this. Okay. So the blue atom is a reference point. So we say that this is at 0, 0. Okay, and the green one, okay, green atom, we say this is at, let's say, 0.5, 0. Okay, all right, is this clear? Now the green atoms are not placed at the, one more comment here, this green atoms are not placed, green atoms are not placed on lattice points. Okay, green atoms are not placed on lattice points. यहाँ पे blue atom is the reference point and these are the lattice points. Okay, these are the lattice points. All right, so you can see from the diagram, if this is 0, 0, if this is 0, 0, all right, so this is the starting point. This will be, the green atom here will have 0.5, 0. Okay,
मतलब सर यहाँ पर ऑब्जेक्ट हमारा ग्रीन एटम हुआ,
ऑब्जेक्ट नहीं, यहाँ पे ऑब्जेक्ट आपका जो है ब्लू और ग्रीन दोनों हुआ है, एक साथ हुआ. ऑब्जेक्ट मींस कम एक साथ ना, बेसिस मींस दोनों साथ में मिला के हो रहा है ना. जो बेसिस है वहाँ पे आपका, दिस इज, यू हैव 2 एटम्स, राइट, सो दोनों साथ में मिल के बेसिस बन रहा है. ऑलराइट, बट वी आर टेकिंग द ब्लू एटम एज अ रेफरेंस, उसको हम लैटिस पॉइंट पे रख रहे हैं और बाकी फिर ग्रीन को हम अकॉर्डिंगली प्लेस कर रहे हैं. ठीक है, क्लियर?
यस सर.
All right, now let's do a more complicated structure. देखो यहाँ पे like what we have here is I've taken half. इसका हमने ये मान लिया है कि ये जो distance है, total distance जो है, like let's say this is this whole distance is let's say a, ठीक है, ये a/2 पे है. All right, यहाँ से यहाँ, तो उस हिसाब से ये half हमने ले लिया वहाँ से. ठीक है, ये a/3 भी हो सकता है, a/4 भी हो सकता है. तब फिर उसमें हमारा ये this will be changing. Okay, this will change depending on, so what we have here actually is this. So this is the green and blue atom. Let me get the blue atom. So this is the blue atom. Okay, and then we have the green atom. All right, so इसको मैंने enlarge कर लिया है, और चलो enlarge नहीं करते, जो same जो बनाया वही करते हैं. So this is the blue atom, this is the green atom. All right, now this is going like this, this is going on like this, the structure goes on like this. So I'm taking just a part of it, वहाँ बहुत crowded हो गया. So this is the structure we had. Now this one, let's say this is at 0, 0. All right, so इसको मैं complete कर लेता हूँ structure को. So this is, so let's say this was the part of the structure. Okay, now we had this thing, we had the basis vectors like this. These are the basic vectors we had, and this was a2, this is a1. All right, so here if you see this, now you can just take this to be, let's say this length to be, you can take this length to be something, let's say a, and let's say this is halfway, the green atom is halfway in this thing. So if we start this as the origin, let's say this is 0, 0, this will be a/2, 0, right? So from here we can derive the basis. Now this explanation which I have written here, this thing, this total thing is a basis. This is how you describe a basis. Okay, उसमें कोई ऐसा a वगैरह कुछ नहीं होगा, ठीक है, but just the numbers. Okay, रेफरेंस पॉइंट हमें पता चल गया, हम ग्रीन एटम को प्लेस कर सकते हैं. ठीक है, ब्लू तो एटम हमें पता चल गया, ब्लू तो हमें लैटिस पॉइंट्स पे रखना है. ऑलराइट, सो आई विल टेक अनदर एग्जांपल. इट विल बी लाइक a more complicated structure. So example, अगर ड्रॉ नहीं कर पाए कोई बात नहीं, समझना जरूरी है, ठीक है. Now this will be a complicated structure. So let me all right. Now I have to repeat this thing over and over again. So all right, so we have this structure, and then all right, so this is the structure we have, and then this is repeated on this side. All right, so all right, and then we have so this is the structure. All right, now in this case, let's say this is given to be alright. This is a structure given to you. Now I'll choose this thing, lattice unit like thing, a unit cell like this. आप कुछ भी चूज कर सकते हो, यूनिट नॉट बी की ऐसे ही होगा, ठीक है. ये मैंने चूज किया, ठीक है. इसका डायमेंशंस जो है ऐसा कुछ है. Alright, ये डायमेंशन इट इज A. This is A. Alright, and इसको हम zoom करते हैं, ठीक है. Zoom वैसे करने की जरूरत नहीं है इसमें, like we do not require it because already बड़ा है. So let's leave it there. We can just use this. So let's say this is D atom. Let's say this is A, this is B, this is C, and this is E. The center one is E. Okay, we have two different kinds of atom right here. We have the black ones and the circles. All right. Now, the reference point is not on the lattice here. Okay, I am taking the lattice point as these. Okay, so this is the lattice point. So this is the lattice. The reference need not be on the atom. Okay, ये भी आप ध्यान रखो, इसलिए example करवा रहा हूँ. So lattice point is at these points. Okay, lattice points, these corner ones. Okay, so this is the lattice point, and this is the reference. I'm saying that this is the reference. Okay, so this is the reference lattice point. With respect to this, we'll define the basis. All right. Now, if I say this is the lattice point, what will be the what can we take this value as? The coordinates as this one, 0, 0.
So there is no atoms in lattice point, right?
Yeah, in this case, that is what the atoms need not be placed on the lattice point. Okay, the reference lattice point need not be a reference point. The reference lattice point need not have an atom on it. Clear? That's why the other example I'm giving you. Okay, it need not be that you have to have placed the atom on the lattice point. It could be the lattice point is somewhere else, but you have a reference. You can construct this structure using this method. All right. So the lattice point here, this will be 0, 0. Okay. Can we define? So let's say this is 1/4 away. So this distance. Okay. This distance is a by 4. Okay. This distance is also a by 4. Now, can we have the coordinates of all the? Can you tell me the coordinates of all the atoms here? So positions of all atoms. So one by one. Positions like A. What are the coordinates of A?
A by 4, comma A by 4.
Yeah. So A by 4, comma A by 4, right? What is the position of B? So these are also
A by 4, comma A by 4.
B क्या होगा?
3A by 4.
हाँ, 3A by 4 plus A by 4. ठीक है? Similarly, C क्या आएगा?
Comma A by 4.
3A by 4 plus क्यों लिख दिया मैंने? कॉमा होगा यहाँ पे. ठीक है? This is 3A by 4. D क्या आएगा?
A by 4, 3A by 4.
A by 4, 3A by 4, and E will be, E क्या आएगा? इसका मान है E जो है A by 2 पे है, ठीक है? So A by 2, A by 2, ठीक है? Now basis. Now let's define the basis. Can you define the basis now? Basis a big circle जो है, ठीक है? जो the circle at जो big circle जो है, or circles you can say, okay? Circles कहाँ पे placed है? Like it is at A by 2, right? A by 2 and A by 2. This circle E, सर्कल एक ही है इसमें, ठीक है? तो यहाँ पे हम बिग सर्कल लिख लेते हैं, ये सर्कल लिख देते हैं. तो A by 2 पे सॉरी, तो 1 by 2 हो गया है ना? 0, 0 ये था, रेफरेंस था, लेटिस पॉइंट. और देन वी हैव द डॉट्स. डॉट्स कहाँ है? सारे डॉट्स को काउंट कर लो. सो 1 by 4 पे है. ओके, नेक्स्ट वन इज, now this is how you construct the whole atoms, the structure, and the next point will be at 3 by 4, and 1 by 4, and the other next points 3 by 4 and 3 by 4. Okay, and then we have A by 4, and sorry, not A will not be there. Okay, and then we have, this is 3 by 4. So we have all the atoms. We can just write this here. You did not write this, so we just for reference. This was for E. Okay, this is for A. Okay, B, and this is for C. This is for D. You did not write like this. Just for your reference, I'm writing like this. Okay, otherwise you will not be said. You will have just given like this. That okay, this sodium atom is at this point, and the chlorine atom is in this point. Okay, that's it. So, how many atoms are there in this basis? How many atoms are there in this basis? This is the base. This is the basis, right? I've written down the basis. There are 5 atoms. 5 atoms in this basis. All right. And what is the number of lattice points in this unit cell? If you take this as a unit cell, this thing.
So 1.
Yes. So this is a primitive unit cell. All right. So number of lattice points is is 1. I hope now things are. Oh, it's already 7:10. You should have shot me. Okay, so we'll meet it at 7:30. All right. All right.
Yes.
Okay.